I'm JP.
I'm Josh.
Today we're going to be doing part 1 of lab 3, which is seeing how there's a correlation between the coolant temperature and the voltage over time. Alright, so right now, to show that we have a bottom end, to show that it's functioning, as you can see we have it disconnected. But right now that it's not connected to the sensor, it's at negative 40 degrees Fahrenheit. Alright, so here's another pin I got. I'm going to show you what happens if you were to short this ECT. So right now we got it back probed. I'm going to short the wire. And as you can see, the PID goes up to 284. But if I were to let it go, it goes back to its room temperature.
Alright guys, so what we're doing now is we did a voltage gap test on the signal wire and made a ground of the ECT. And we're watching the coolant temperature go up while the voltage goes down.
Alright, so right now that time lapse that you just saw showed the voltage dropping from 2 volts, and right now it's at about half a volt. It's sitting at a steady 185. That is probably just because the thermostat finally kicked in. It's at operating temperature. The car isn't under enough load that the fans kick on. That shows the correlation, the negative correlation between as volts resistance drop, the temperature rises.
This is a 1999 Grand Cherokee with a 4.7 liter V8.
This is a throttle position sensor, part of the lab that we have going on. Here's where the throttle position sensor is located. The throttle position sensor is a potentiometer. This one in particular has a contact that runs on a variable resistor that changes voltage as the position changes.
Another potentiometer on the vehicle that has to do with the throttle position sensor is the accelerator pedal position sensor. Works off the same principle. It's a sliding contact that runs across a variable resistor. Well, this one's actually cable driven, but on most other drive-by-wire, it is a potentiometer.
The importance of the TP sensor is that it is an input to the PCM that allows it to govern whether it adds more fuel or less fuel, depending on what the position is. And that it is given by a digitalized signal through the signal wire and the position of the sensor.
This is the throttle position sensor. This is the IAC. This is the IAT.
Here's the breakdown of the throttle position sensor. On the computer, it says that the first wire is a 5-volt supply, which is the red one, which is the first one right here. And then the second one says is a signal wire right next door. And then the ground wire is black. So we actually back probe the signal wire on the TPS. And then right now it is at closed throttle, which reads at 0.6 volts, which means it is in range. We wide open throttle, which actually goes up to around 4 volts. Then when close the throttle on the CPS percentage, we can see that it's actually at the very bottom. Open throttle, fully then halfway, and then close.